are the core differences that Scrum Masters and Agile coaches should be aware of when transitioning from traditional software development to data science kind of an engagement?
Okay, that's a great question. So one thing to begin with, right? First of all, right, be it a Scrum Master or an Agile coach or even a project manager, one need to understand the life cycle of the data science, as a whole, like in terms of understanding the problem. What is the problem that I am trying to solve by actually building a predictive model using the concepts of a data science? I think typically in an Agile, what we try to do, we take a small set of requirements and then try to go through the pipeline of requirement analysis, the design, development, testing, deployment. We cannot use that concept as it is here because we need to, so we need to juxtapose that particular concept with the data science life cycle and then try to tie the knot, typically at a point of minimal discordance. If I want to, probably an Agile coach with a data science knowledge can actually encourage that flavor of experimentation in a better manner, can share for example, and one also need to understand the data science, the actual pipeline which has been built over there, how the models are getting trained and validated and deployed, and ask some powerful questions. Okay, even if you don't understand the mathematics behind it, nothing prevents an Agile coach to ask why certain models were chosen here. What is the pros and cons? Okay, why are we going for this? Why are we going for this particular model? I think somewhere we need to begin the journey and then get going from there. Okay.
Imagine you are leading a data science project, trying to bring the power of Agile to complex AI initiatives. But how do you reconcile the experiential nature of data science with Agile's structured approach? How do you adapt Agile framework, manage stakeholders, and ensure you are delivering real value? Today, we are diving deep into these challenges and uncovering practical strategies with an expert who has been at the forefront of this intersection. Today, we are tackling a critical question. How do we effectively implement Agile in data science and AI-driven IT engagement? It's a complex domain requiring a unique blend of Agile ways of working and data science expertise. To guide us through this, we have Balaji T as our guest today. Balaji, an IT professional with 24 years of experience, including 15 years in Agile. He specializes in pragmatic Agile, digital and strategic transformation, and organizational change management. He's passionate about executive coaching in IT and data science initiatives and currently focuses on the merger of Agile CoE, Enterprise AI CoE, and DevOps CoE. Let's explore how to bridge the gap between Agile and data science realities. So without further ado, let's begin.
Hello, Balaji. Welcome to the podcast by Agile Coaching Roundtable yet again. It's a great pleasure having you on our show. Thank you so much for joining.
Yeah, gladly. Glad to meet you both again. Cheers.
Same here, Balaji. So we are really excited and looking forward to this conversation. So today we want to have a conversation on the latest buzz that is going on in the market, right? That Agile in this entire AI engagement. So how do we integrate Agile in this entire AI scheme of things, right? So obviously, whatever I have experienced myself, because I'm also working in an AI organization since last 4 years, and I know you are also doing the same for your own organization, setting up some best Agile ways of working at a very large scale in your organization. So we thought it would be a great opportunity to connect with you and have this conversation over a podcast. So maybe to begin with, data science or maybe AI projects often differ significantly from traditional software development. What are the core differences that Scrum Masters and Agile coaches should be aware of when transitioning from traditional software development to data science kind of an engagement?
Okay, that's a great question. So one thing to begin with, right? First of all, right, be it a Scrum Master or an Agile coach or even a project manager, one need to understand the life cycle of the data science, as a whole, like in terms of understanding the problem. What is the problem that I am trying to solve by actually building a predictive model using the concepts of data science? I think one need to primarily begin the journey from there. So the business understanding of the problem, and in terms of getting the data set ready, like in terms of preparing the data and to understand the data to build a model, because we cannot take a raw data and then definitely go for building the
Absolutely.
yeah. So we have some concepts, okay, which I will cover later. We have something called feature engineering. We have something called exploratory data analysis, and we have some concepts like curves of dimensionality reduction. So the point to be kept in mind is we cannot take a raw data directly and then try to build a model as such. So we may need to do cleansing of the data, or if I want to use a layman term, cleaning the data. Of course, that the technical term could be data pre-processing and feature engineering. But if I want to use the layman word, cleaning the data, or rather cleansing the data so as to make it deemed fit to build a model. And then no, probably I need to build a model, actual model, and I may need to evaluate the model. I need to validate the model, and based on the observation, I may need to fine tune the model, which we call as a hyperparameter tuning and all, and then possibly deploy the model. So the way of thinking itself is more of a exploratory journey. It is not like a well charted territory, right? So definitely the scrum masters and agile coaches are no, be it no any role who is working in a typical data science project need to master the data science life cycle, and then think about, okay, if I want to coach my product owner to slice a user story, then possibly you cannot slice a user story just by using your invest techniques, whatever you have been using in your software,
Correct.
right? So you also need to understand the different user personas. Like you have a data scientist, you have a data analyst, and you have a
Engineer.
MLOps engineer. So probably you can even go for a role-based sizing, the slicing of the user stories or the features, what we try to encapsulate. So I think no, these are some of the things which we need to keep in mind. And one more important point is when you are interacting with your business sponsor or the key stakeholders of the project or your client, you need to have the storytelling ability. Means what is the business problem, why am I building this particular model, and how this particular model is really going to solve the pain points of my end user or the customer. And definitely every model comes with own limitations, right? When you build a model or any kind of a solution capability, one need to be clear on the assumptions, dependencies, limitations, and the constraints. So I think be it a scrum master or be it an agile coach, one need to be cognizant about the landscape or the ecosystem, and at least the basic concepts of data science life cycle as such, and who are all the different actors in that particular user journey. Accordingly only we may need to take it forward. That could be a way to begin with. Probably you can share your views too, like to exchange our thoughts.
Well, maybe to begin with, I think, as you mentioned, right, data science projects are maybe not exactly what a traditional software development is. Basically, as you shared with an example, saying if I've been using a slicing technique of invest, maybe that not might be the right fit over here. Maybe more focusing on how a user persona, maybe based on those, we should help the product team, or maybe the coaching to the product team should be in that aspect. While saying that, maybe as you know, given the exponential nature of the entire data science ecosystem, right, and how data science projects are maybe short term or maybe short lived, right, based on what we have experienced. How working, especially when they are into core traditional ways of working. So, what's the difference in a core traditional way of working while comparing it within a more data science project in an agile way?
See, typically in a data science project, the definition of done is more of a fluid type. We don't have something which has been carved on a stone per se when it comes to the definition of done.
Correct.
So it is more of an experimental type of an approach. See, even in an agile project, right, we used to have a spike user stories, right? And similarly, we used to have a enablers predominantly at a feature level, typically to build our architecture runway. If I want to use the
Correct.
nomenclature or the terminology of a SAFe, the scaled agile framework, just to give a example. So see, for example, let us take a simple use case. Okay, we can take multiple use cases. One of the simple use cases, let us say the the meteorological department of some country wanted to build an AI model or an artificial intelligence model to predict the cyclone in a particular region. Okay, so some people used to pass a funny comment on a hilarious note saying that if the government says rain will come on Monday, definitely the rain will come only on Tuesday. See,
Correct.
but we also need to understand we are trying to monitor or study the nature of a system which is too dynamic. You cannot fit into a linear equation like y is equal to mx plus c. Okay, there are too many parameters which are definitely beyond our circle of influence, and when those parameter changes, all the predictions what we try to simulate using model goes for a toss. Even in the case of COVID-19, when the medical team was trying to build a model to design a solution or to envisage a solution, COVID-19 started having the mutation, the kind of a mutation.
Variant.
So your robust Monte Carlo simulation also goes for a toss in a totally chaotic and unpredictable kind of a thing. So I think this is a typical challenge. It's a kind of embarking on an uncharted territory with a limited permutation combination. That is why in a typical data science projects, it is always better to spend at least 50 to 60% of the total time in terms of preparing the data, because garbage in, garbage out. So we need to have a data set which is comprehensive enough, but not really biased also, removing the outliers. So we have some concepts over there. So the point to be kept in mind is the more we spend time on building the data pipeline or the cleaning the data or the data set, better will be the predictability score for your model, a kind of a thing.
Okay. So maybe Balaji, I have a follow-up question on this extension to what Vivek asked, right? So obviously, as I mentioned, I also work in the AI-based organization. So I have seen these things firsthand. So whatever you're speaking about, I'm able to kind of relate it to the great extent, I would say. So given that the projects or maybe engagements or assignments, whatever we want to call, in this AI space or data science kind of a projects or data engineering kind of a projects, they are very short term in nature. Meaning, so like all of us have experienced that we have like prolonged projects where it goes beyond an year or maybe it goes for years together. Whereas when it comes to data science kind of an AI space kind of a project, the projects are like this short, like within 3 months you will be the project that we were working on is finished and we are moving on to the next project. The reason being because, as you rightly mentioned, we are working on the predictions and tools and kind of a things. So the projects are not long lived, right? So in such kind of a scenario, we as an agile coaches or scrum masters, how are we going to implement or teach them the agile ways of working when it is such short-lived kind of a projects, right? Because it becomes so we teach something or maybe we ask them to experiment something in terms of say processes or maybe framework. By the time they do and get used to it, the project would have been already done halfway, right? So how are we going to address this kind of a thing?
Typically, from a pragmatic approach, right? From my experience, of course, what really happens in the industry is probably like we have our Agile CoE. Many of the companies have started thinking about AI CoE, your enterprise AI CoE. So typically, your AI CoE is by nature, it is like a horizontal capability which is going to cut across to, or rather to cater to the needs of diversified clients or customers. Okay. But then it all actually depends upon, okay, I have built a model. Now I need to think about the scalability of the model in terms of deployment for my futuristic envisaged needs. So in some cases, no, let us say you have a DevOps pipeline or you have a DevSecOps pipeline. Even in your DevOps and the DevSecOps pipeline, you can take a business use case and you can use your artificial intelligence to do a robust predictive maintenance kind of activities. So by nature, typically data science projects, if you are taking some, okay, from my experience, I'm saying, if you're taking some companies like Walmart or rather a PayPal kind of a kind of a clients or a customers, it actually once again boils down to the degree of complexity of the use case or the business case which we are trying to solve, right? Because for some complex business cases, it may typically take even 4 to 5 months to collect the data, to build a feature engineering, and to complete your exploratory data analysis itself. Okay. So typically in an agile, what we try to do, we take a small set of requirements and then try to go through the pipeline of requirement analysis, design, development, testing, deployment. We cannot use that concept as it is here because we need to, so we need to juxtapose that particular concept with the data science life cycle and then try to tie the knot typically at a point of minimal discordant. If I want to put it in some English words, try to tie the knot at a minimal point of discordant so that you take care of your feature engineering, all those things. See, from my experience, right, uh, like like we have a difference between a good coach and a great coach. A good data scientist will always try to build a model which will predict the future accurately. Whereas a great data scientist will try to envisage new possibilities on the horizon. It's not just confining to build a model. By this model, can I create something new? I think your Gen AI, Agentic AI, all these things came from that particular thought process by seeing possibilities on the horizon rather than creating a model to predict the future.
Correct.
Okay, that's my view.
Wow, I love that last aspect or maybe thought around it, right? But maybe again into this aspect of what we are talking. Uh, Obviously, when we work in a data science projects, or maybe how this entire ecosystem, I would say, is dynamic in nature in terms of uh, trying to be more predictive or trying to use certain models to get an outcome in terms of the results and everything, right? Since this is a unique you know again, I'm not sure whether I should be using that word unique, but since it's more different compared to how traditional projects are, we also need specialized skills and tools specifically in this aspect, right? So how can a framework, as you said, right? My typical framework will never fit into the aspect of it, and we need certain bindings definitely over here. So can we be more adaptive in terms of saying that, okay, we might be working in a typical framework, say it might be a scaling framework, or maybe let's say it at a team level as Scrum framework or any other framework, but while being adaptable towards that framework or while using that framework, can we still be have our own flavor of uh, maybe customizing it in a way that fits our purpose?
Yeah, so to answer your questions, right, probably let me actually put like in this manner. We actually always have something called the principles behind the practices because typically
Yeah.
framework operate at a practice level, be it agile, be it lean, or be it even data science. We have always something called principles behind the practices. So what is more important? We need to prioritize the value over building a feature, right? So typically in a data science project or a data science kind of a flavor kind of a project, typically what happens is we need to use a time boxed experimental, no, we may need to use, instead of a typical user story, we may need to use something like a time-boxed experimentation with a clearly defined hypothesis. And this particular hypothesis needs to be validated. For example, can I build a model? Can I build a model which has the capability to predict the customer churn rate with a precision of 85% using the current transactional data? Okay, this is the goal. Okay, so I define the hypothesis. Now the focus is, instead of focusing on shipping a perfect machine learning model or a ML model, I need to focus on how soon I will get the insights fast, and how those insights are really getting aligned to the pain points of my end users or the customers. So some of the things which we may need to have a paradigm shift in our thinking processes. We need to probably start thinking even uncertainty as a feature and not as a bug, probably in our
Well
thinking
said.
pattern. Yeah, uncertainty as a feature rather than a bug, because a bug is something you always have a clarity on the expected value, wherein you measure the actual value against the expected value and you do a discrepancy. But in the typical data science project, sometimes the target itself is slightly moving always. You are trying to hit a moving target, right? So I think those are the things. And typically Kanban, like a framework like Kanban, which typically based on the item-based flow approaches, could be more suitable. What is more important is understanding the different roles of the people involved in the project and accordingly creating a user stories so that the work nature pertaining to the role of the people exactly matches with the task what they need to do. So I think a mix of a Scrum or a Kanban model can be used for more flexibility. And for example, right, user story format. As a business analyst, I want to do XYZ. As a data engineer, I want to do ABC, right? As a data scientist, I want to do XYZ. So what is that XYZ? What is that ABC? Typically come from the ecosystem, but you may start writing user stories which will map in terms of the granular level work activities of the team. I think probably these are all small things we may need to start at doing. And most important is, from the practical approach, like we create an agile playbook, right? Why don't we have a data science playbook itself, right? Where not typically in your data science CoE or your AI CoE, when you have some more expertise and experience in different varieties of the projects, one of the things is that you come up with a data science playbook, which will at least give you that template. Okay, what you put inside the template will change from context to context, but at least I need to be clear with the I need to be clear with the variables. The value to the variable will come from the context. In an interview, if we say for every question, it all depends,
It
it all
depends.
depends, definitely the interviewer is not going to select us, because the interviewer also
True.
knows it all depends. Interviewer wanted to know from you, it all depends. Agreed. Based
In
on
your
what?
experience.
Based on what parameters? ABC. Then what is ABC? Based on what parameters? XYZ. If you keep on telling it all depends, even if you are taking interview, you will not select the candidate, right? So I
Absolutely.
think some kind of a structured approach need to be harmoniously blended with a flexibility based on the dynamics of the engagement.
Wow. Very well
Right?
said, Balaji. So, a couple of things I would just like to highlight. So, one is the point that you mentioned about, say, playbook, right? I would
Hmm.
also like to maybe go ahead and say that why don't we create an agile playbook kind of a thing wherein we say that, okay, roughly, I mean, I'm not saying that this is how you should be doing it, but obviously, like a framework, right? What we say, framework is just a loosely held rules which we can tweak. Similarly, when we say that we are working in such AI based or a data science and engineering kind of a projects, roughly this could be a framework or this could be a playbook, agile playbook, wherein this is how we can do. Maybe that could also be one of the ways. And also to the point that you mentioned earlier, right? That the uncertainty is itself a feature, unlike bug, right? I would like to add the way we talk about the iron triangle parameters, right? The cost, budget, and the timelines. I would also say that for these kind of projects, uncertainty is also one of the constraints or parameters, I would say, that we should be considering when we work with these kind of emerging technology kind of a projects, right? So what do you have to say on that?
Yeah, that is quite true. But again, see, when it comes to the ground level execution challenges, we also need to factor the domain of the project. For example,
Correct.
a data science project in a banking domain is something different from a healthcare domain versus some other domain. So typically, your subject matter experts or your business analyst may be able to guide on certain aspects or dimensions. The other thing is that yes, from a tech stack compatibility, we also need to look into it. Then how are we because it is a data science project doesn't mean that we will not be factoring the governance and compliance and any other regulatory mechanism. So how are we going to uh, incorporate even those particular aspects or dimensions of governance into the overall larger framework? I think these are all the different things which we need to do. But for a large scale data science projects, again, it is always better to do a hypothesis validation or some kind of a
Correct.
proof of concept or a pilot initiative and then take the learnings from there. See, one of the challenge here is, typically when it comes to data sciences, it is similar to Agile. We have multiple frameworks in the market. But what is more matters is, given a scenario or a use case, which particular framework will be the closest to fitment. Similarly, in the world of data science or your artificial intelligence, you have something called as a supervised learning, unsupervised learning, and something called as a reinforcement learning. And within each of these types, you have different kind of algorithms, and every algorithm has its own pros and cons. Knowing the pros and cons of different algorithms and then taking a strategic call based on the limitations of the ecosystem, which particular algorithm will be the closest fitment. I think in that case, data science, though it is called as a science, definitely there is an art element behind it. Okay.
Well,
When I wrote my LinkedIn articles, I have written one article saying, "Is data science is just only science?" Yes, of course, agreed. It has an elements of science, but certain things is that you may need to do some trial and error. You may need to speak to someone who had already done it. Then you will be getting, wow, I have not factored this way of working, right? Right. I think those are all some of the nitty-gritties or the subtle nuances which we also need to keep into consideration. The bigger challenges, okay, agreed upon, we have this particular uncertainties. Now, if I have a release plan from an organization level, or if I have a milestone level plan, how am I going to do the match the following, right? You have your
wow.
data science, life cycle on the left side, agreed. On the right side, you still have your milestone level planning, your release level planning from an overall program or your engagement perspective. Now, how am I going to do the match the following between the left and the right and create my MVP model for further validation hypothesis and all? I think that is a place where data scientists also need to spend more amount of time with extensified group or diversified group, and then collectively we work together. I think these particular challenges applies to any stream for that matter,
Correct.
right?
Correct.
Okay.
Concept is one thing, implementing the concept is one more thing. And then in terms of the delivery, we cannot deliver just like that. No, you have a predictable cadence which is expected from a company level release planning. So how are you going to fit into that equation is something which we may need to see.
So, Balaji, while you were talking about certain milestones or how we, can match it maybe from an left to right, right? So maybe that's where I'm trying to understand. In if we're talking about milestones, right? How do we, in such kind of a projects or use case, what metrics can be, you feel can be more relevant for tracking progress as we are talking about milestone, right? So maybe which determines or helps us to understand the success maybe in such kind of a projects.
See, okay. So, for example, see, success needs to be definitely defined at an engagement level. Preferably, if it's always better to quantify your success criteria at an engagement level. Okay. Now, from a commonsensical approach, time to production is actually one of the metrics, right? Be it a data science project or be it any kind of a any kind of a flavor, how soon, how long will it take for me to do an experimentation and then to go from idea to a deployable model onto the cloud? Because unless and until something goes onto production cloud, unfortunately, it doesn't start giving business value to my end users,
Correct.
right? So from that perspective, time to production is a key metric, and we have certain metrics, like, because we are trying to talk about something like a data science kind of a flavor. What will be the cost factor involved for me to train the model and to retrain the model, right? From an operational efficiency perspective. Okay, now let me tell the reality. Now, what happens in the industry is, if something goes wrong in the model, let's say the model starts giving me some kind of a business results which is not in tune with the ground level reality, I need to come all the way to check the raw data set what I collected. I might have collected the raw data from the organization or from a client organization database, or I might have used something like a
Third party.
third party APIs or web scraping to actually collect the data. Probably I may need to know. So it actually comes with a cost to once again complete the loop. That is why we always say you spend a reasonably good amount of time to actually clean the data, make the data really fit enough for you to build a model. Don't try to force fit the model like what we see in Agile, right? Don't try to force fit a framework just because it has been told. Ideally speaking, you need to take the best practices from multiple frameworks and try to build your own customized Agile framework. What we talk over there makes relevance here too. So probably in terms of retraining aspect, what would be the cost and your adoption rate, right? If you have built a model, then uh, okay, and now how I can actually this business actually use the insights from the model and then try to gain some kind of a benefits out of it. Okay, and one more thing is, we have something called as a data drift monitoring. It is something like, whenever you are actually talking about the distribution pattern of the data which is going to change over time, then how does the reliability of the model can be embarked upon? I think these are all some of the a kind of metrics which we can think about from an agile or rather from an agile data science combination to begin with. Based on the need, it may change later.
Correct.
Or your thoughts, any
Absolutely.
one? Yeah.
Yeah, absolutely. I mean, I agree with you. And one of the other things, I don't know whether to put it as a metric or maybe a measure or whatever it is. Other aspect that I also feel is reusability of the models, right? So how our models are going to be reused in a similar kind of engagements, or even in the current engagement also. As you rightly mentioned, if we are going to go back to square one for data extraction every time, what is that framework, or how are we going to reuse what we have built, right? So that is also something that I feel we should be including, whether it could be a
Yeah.
metric or it could be a measure.
Yeah. So while we are talking on the reusability metrics, so generally one way to look at it is, any model or rather any solution which we have built for that matter, we need to have some 4 or 5 checklist or rather the checkpoints. One is the reusability, second is the reliability, third is the predictability, right? And scalability, sustainability. So let me repeat these 5 points for the benefit of the audience when this video goes on YouTube. While we are actually focusing on the reusability, we also need to look into the repeatable or the recurrence pattern of that model, which is somewhat closer to the reusability. Of course, the model should be credible enough so that future can be predicted using this particular model. Yes, this model works in these cases. When I scale it up to a larger dimension, whether this model can be scalable, right? See, even in scaled agile framework, as the name indicates, yes, I have a framework at a team level, but if I want to do it at a program level, at a portfolio level, at an organization level, is the framework that has the capability to scale up? Then what is more important is, the results or benefits what we get should be sustainable over the long run, right? I think these are all 4 or 5 things which we need to keep in mind for any engagement for that matter. Yeah.
Absolutely. Absolutely. So since you're talking about the scalability, right, of the model, so as data science initiatives grow, scaling becomes crucial, right? So how can agile practices be scaled to support large-scale data science initiatives and integrate them with the existing systems?
Okay, so one of the aspect or a dimension which we need to keep here is there is something called a platform thinking. Okay, what do you mean by platform thinking? Instead of trying to build a one-off model, can I build a reusable ML platform, which could be one thing. Second thing could be CI/CD adoption, wherein your MLOps has been integrated into the system. So nowadays, see, gone are the days we talk about DevOps, then we talked about DevSecOps, then we actually talked about biz DevOps, business and DevOps. Now we are actually talking about a MLOps adoption. So one of the thing could be in my CI/CD pipeline, do I have that capability or that trait to even encapsulate MLOps, and how am I going to automate retraining of the model and deployment? That itself can be taken as a use case for certain validations. And we have one important concept called okay, I'm not sure you might have heard this term. We have something called as a federated teams. So what do you mean by federated teams? If going back to the principles of Agile, right? If I build a squad, here in the case of this particular ecosystem, I may need to build one team for research, one team for production,
Exactly.
and one team for integration. So we call this as a federated teams. So to answer your question, when we are trying to scale up in a large scale data science initiative, how am I going to position my federated teams in the overall ecosystem of the client landscape? That also we may need to look into consideration. Data governance becomes a bigger challenge because you need to do data quality checks and model validations as part of your CI/CD pipeline. And these models also need to be monitored. So, and for example, right, this particular federated learning, how am I going to what to say, make use of a decentralized data and self-service AI pipeline? If something goes wrong, whether that AI pipeline has the self-service capability to do it. I think these are all typical challenges which one may have no from a pragmatic approach when you are trying to scale up a data science kind of a project.
Okay, so
Yeah.
since we are talking about few of the challenges that teams might encounter or might be going through, right? Again, one of, I won't even say challenges. One of the uh, expectation is how quickly we can, deploy something, or how we can not typically validate it something in the right way, which we are also talking a while ago. So how do you see, with the integration of AI? This becomes much more convenient or comfortable for teams doing it. I mean, would you like to talk about that as well?
See, okay. So one thing is that, see, in some of the companies, what they typically do is they have their own in-house accelerators or enablers, whatever be the term called, because the term used may change from companies to company, and I don't want to give the exact terms of the platform, because when I say it, people will know for which client. All that I'm trying to say is, as part of your enterprise AI CoE, what is like we have our Agile CoE, one of the common thought pattern is it is also for capability building and reusability. So the point here is many of the companies have their own AI kind of a utility. Instead of using the word accelerator enabler, probably I will use a better word, utility. AI called AI kind of a utility which can be integrated on a need basis, and it will start supporting shadow deployments. For example, you are actually trying to deploy the model in parallel for a live testing before actual full rollout, and you also go up to the extent of treating feature engineering as a code. Means what? You automate your feature pipelines so as to avoid manual errors. And you can also think about using CI/CD for your ML, like your GitHub Actions or your ML flow. So in such cases, one of the challenge could be, okay, how am I going to use my pre-trained model as a baseline? So instead of starting something from the scratch at the beginning, there is something called a transfer learning, right? So can I use my transfer learning or my fine tuning existing models to accelerate the deployment process? And also now trying to think about your canary releases for your no, uh, ML models. See, the concepts of feature toggles, canary releases, dark launches, everything holds true, even in any kind of a project. But what we actually deploy, it actually need to be changed. I think these are all some aspects which we need to keep in mind, because unless and until I know the context, no, I cannot give an exact answer. So I'm just trying to give answers at a principle level rather than a practice level.
Absolutely. I mean, yes, I mean, since I have worked in this scheme of things, is why I'm able to relate to what you're saying. Obviously, for people who are like new, they would maybe it would take some time to wrap their head around, unless and until it's like working in safe, right? It is difficult to understand the concepts unless and until you yourself work in safe. Similarly, unless and until people work in this kind of environment, it is difficult to kind of understand or maybe grasp or maybe sink in all that we have said. What
Yeah,
I could relate to what you were saying, right, on the MLOps front. So for us, from the agile space, first we said like, okay, we need to add knowledge on this say DevOps thing or maybe engineering practices kind of a thing. So now
mm,
what we are trying to say is add a layer of MLOps to the DevOps that we are already doing, so that that itself becomes as a integrated function. And whenever we want to do a deployment for a similar kind of a projects, we use that as a kind of a function that is available, and if we require, build upon it, top it down, and then use it for your own use. So this is what
yes.
typically we are also doing in our own organization. Maybe we are not calling it the team that you said, but yes. So what we try to do is we publish kind of a case studies saying that okay, this is what we have, this is the model or this is the function that we have built. If anyone needs it, maybe you can build upon it as a this is a baseline. You can build upon it, and then we kind of use it for your own purpose, customize it for your own purpose, right? So this is what we are typically trying to maybe
Yeah.
talk about.
Yeah. But one point here, see, one point which I like to say, which I felt as a really important point before we go to the next question, we need to understand one very basic concept here. Data science is a multifaceted cube. It is not a single competency or a capability. Like if you take a cube, right? You have 6 sides of the cube, right? If we paint the cube with different colors on different side, one is like yellow, green, blue, we will be getting 6 colors, no? So data science is like a multifaceted cube. For example, one need to be good in the programming language, so preferably Python. If someone is aspiring to become a data scientist per se, one need to be good in one of the programming language. So in the market we have R programming language, or you can go for Python. I personally prefer Python. Is a better programming language, powerful, because Python gives lot of inbuilt functionalities, library files as a capability which you can import and then use it. For example, NumPy, Pandas, or rather Matplotlib. So you have a lot of things which you can reuse. So one thing is from the programming language. Second thing, one need to know the basic IDE, right? If you are using PyCharm, let's say PyCharm for Python, you need to be comfortable with the basic IDE, where you are right to write the code, and how are you going to do the navigation. Then what is important, you need to be good in the machine learning concepts. Okay, so in terms of the machine learning, then you are a deep learning concepts, you at least need to know when to go for a classification, when to go for a regression, when to go for a reinforcement learning, some of the concepts of a machine learning, clustering techniques, this thing, that thing. So these things we need to know on a high level. Then when it comes to deployment, of course, we some companies have something called as a Flask framework. Okay, so Flask framework, you also need to know, okay, how does the code can be deployed onto Azure or AWS EC2 instance per se. Okay, now these things is on the programming language, the algorithm side, and then this. Now what about mathematics? Definitely you need to be good good in your calculus, your algebra, and your stats. When to go for Poisson distribution, when to go for Poisson distribution, when to go for normal distribution. So that amount of knowledge is needed. Then as obvious in terms of feature engineering, your exploratory data analysis, all those things, one need to be good. The other important thing is, let's say I have done everything. What is more important? I need to have a model. All these things are okay. What about visualization? Because my business cannot come and see the live code which is getting deployed onto the prod, right? Ultimately, they want to have a Power BI report or a Tableau report to see your data analysis. Just to summarize, right? Your programming language capability, your machine learning and different algorithms around it, and your IDE, your deployment, your mathematics, some amount of either a Power BI or a Tableau. I personally prefer Tableau over Power BI because Tableau gives the capability to build lot of customized reports within a quick span of time. Of course, it also comes with a cost slightly more than the Power BI, depending upon the licenses and the contractual obligations between the business partner and the client. So I think these are all some of the things which one need to be cognizant about. Then you can think about how to map your agile practices on top of this. If these concepts are not good, I don't think one can contribute to the data science community just by knowing agile. Or how do you think?
So you summarize it so beautifully, Balaji, to be very honest, in terms of, I would say it's like, in a short 5 minutes, you have defined, or maybe not even defined, I mean, given an ecosystem of how this entire data science world looks like, right from understanding the programming concept, or maybe understanding the ID, or maybe the ML languages that one needs to understand, and the deployment aspect of it. And the most important aspect of how do you visualize, or how do you give that visualization to your end customer, and then over that, how your agile practice are going to help that, right? So that was so wonderfully, I mean, beautifully explained by you. uh,
Sure.
yes, again, while you were talking about this, I again believe or see it as, some practical tips that an agile coach or scrum master needs to understand, or need to be aware about when an individual is going to be part of that team which is more inclined towards data science projects, right? This is what, as a practitioner, one needs to be aware about. Maybe if not technically end to end, but at least having an understanding, as you said, right? What is your IDs? What are the maybe the ML languages that one needs to be aware about, or maybe certain visualization tools that is going to be helpful when uh, a practitioner is part of a team which is talking in that language, right? So this becomes a significant tips for them. Any other tips that you would like to share, for agile practitioners who are part of this ecosystem?
Generally, budding agile coaches have this particular misdirected enthusiasm. Okay, from my experience, of course, budding agile coaches, what they do is that as soon as they get into a program, they actually try to introduce too many changes within a short span of time. Okay. Okay, it is not a movie. It's not like a movie where the hero comes and then does something, and then everyone, everything. That's not the way a real-time ecosystem works. So typically for an agile coaches or a scrum master, what I like to say is, first of all, you understand what are we trying to do in that particular project for any role for that matter. Because see, let us talk pragmatically. Even if you're taking SAFe as a framework, Philips implemented SAFe, Siemens implemented SAFe, Ford implemented SAFe framework, Wells Fargo also implemented SAFe, let's say. But their problems are similar but not same. There is a difference between similar versus same, right? So though they implemented the framework, there is always a subtlety why they go for such framework. So along the similar line of thought, whenever an agile coach joins a data science project, whatever we have discussed till now, right, at least the basic knowledge of the ecosystem one need to have. Okay, then probably one can sit with your business SMEs, or you may have one product owner or someone from the business side to see how the requirements can be sliced now into consumable user stories. What stories we can give to a data engineer? What stories we can give to an ML engineer? What stories we can give to a data analyst? And for you to give sliceable user stories, if you don't know the data science life cycle, you cannot coach them to slice it in a better manner, right? So,
Absolutely.
so these are all some of the places where the domain. So what I say is, whenever you are joining any project, first for the 1 week, be a very good listener. You participate in the calls and then try to know the ecosystem. Okay, what these guys are discussing. Even now, I always prepare for my office meetings. I don't go to the meeting and then think what I need to deliver. And sometimes if there is a prelude or a prelude material that needs to be sent, we actually send the material. And even now, I generally take notes, a small kind of a notes. See, I am a guy who don't believe in the digital notes. Okay, my personal thing is I still prefer physical hard copy notes, because digital notes, once your cell phone battery goes down, you are gone. But I still believe in physical notes. I take notes and I try to understand. Okay, this meeting happened for this purpose. What is the periodicity of this meeting? If this meeting happens bi-weekly, how I need to prepare well for the next meeting, so on and so forth. The second thing is, build some rapport with all the people in the team, right? See, if your business analyst is not going to spend time with you, then how are you going to know the functional SME part of the project, right? So,
Correct.
correct. So, even see, your agile knowledge and other things will give you some techniques to operate. But again, how those techniques can be fitted into the ecosystem, unless and until you have a good rapport with your product owner, your business analyst, your tech leads or architects, the magic is not going to happen. Because ultimately, the magic never happens with tools, techniques, and process and frameworks. Magic need to happen with the people only, using tools,
Absolutely.
techniques, and using tools, techniques, and process, of course, right? So what tell people is, you understand their own pain points also, and if you try solving their pain point, they may also help you better in the future, because life typically runs on value exchange, right? You give them value, they also provide you value back. I think these things are needed for any role, for that matter, not really confined to a kind of uh, a kind of a agile. Now, to answer your question, right? To answer your question, probably an agile coach with a data science knowledge can actually encourage that the flavor of experimentation in a better manner, can share for example, no, and one also need to understand the data science, the actual pipeline which has been built over there, how the how the models are getting trained and validated and deployed, and ask some powerful questions. Okay, even if you don't understand the mathematics behind it, nothing prevents an agile coach to ask why certain models were
Absolutely.
chosen here. What is the pros and cons? Okay, why are we going for this? Why are we going for this particular model? I think somewhere we need to begin the journey and then get going from there. Okay, I may not have a direct answer to your question, but these are all some points which we need to keep in mind for any role, for that matter, right?
Absolutely. I mean, that's the way to go, right? I mean, this is what I work for me. So whenever I get into the projects, right? I mean, be it data science or AI world, or be it any other project. So be it IoT or data, whenever we are getting into a new world, obviously we are the lost kid over there, right? So we need to fit into that milieu and that environment in a way that we are part of them, right? We are not someone outsider and versus insider kind of a thing. So what I try to do is, whenever, especially this is true for these data science kind of a projects, whenever I get into the project, I go to the team, talk to them. First thing I submit saying that, you know what, this world is new to me. I don't know a thing. I don't know anything about this project. You teach me what is this project is all about. And first thing I try to understand is the architecture, end-to-end architecture. How does it look like? So once I understand the concepts of it, right, not necessarily having the hands-on experience of how they are doing, what is the statistics behind it or a mathematics behind it. but understanding the concept end to end flow, then I can understand, okay, this is the concept. Now, this is what the world is all about. This is how I can help them. So, this is what has worked for me. And as you rightly mentioned, we just cannot go unprepared for any kind of a meeting. So, we have to prepare saying that, okay, now this is the agenda of the meeting. So, this is what I can bring it to the table, right? And one way that has helped me help teams is having a lean goals. I mean, since the experimental nature of this entire domain, right? So I asked them, do not have these fat goals. Have your goals very lean. It's okay if you have to maybe redo it again and again. Maybe I would say if 2 week sprint doesn't work, have 1 week sprint, but have a leaner goal so that you know that you may have to change things. So next sprint, you may want to experiment on something else. So this is what has helped me just to add to what you have mentioned, right? So this
Yeah,
is what works for me.
and one more thing, no, as I mentioned in our previous video also, having an internal organizational connect is very important because you may be looking out for a solution by talking to a US guy or a UK guy sitting in Chennai or Bangalore. The guy who knows the solution will be right just opposite to you, but just a table away. And to catch out of that guy, people write mail to someone in US, and that mail will be forwarded to someone in UK or Australia. And by the time that guy comes back and tell, hey, this guy is just seated next to me. So for any engagement, generally, it is always better to know, okay, what are all the different teams. So in some places we call it as a cluster. Okay, you have a cluster head, you have different cross-functional teams conglomerated into a group called as a cluster, and there is a strategy behind why am I forming a cluster. Okay, every cluster is been mapped back to the OKRs or the KRAs and KPIs at an organization level. Only thing that probably it is not told to us, but that doesn't mean there is a randomness in it. Okay, so we call it as a method in the madness, going by the the English phrase. So okay, what am I trying to say is definitely having an internal organization connect is always important, because a similar problem those guys might have solved for some other case, of course a different, slightly different use case. So you no need to always reinvent the wheel from the beginning, from the scratch. That is the core concept of your CoE. Also your CoE need to act as a central hub, not just for forwarding mails to create brand awareness, but also for real-time capability building. Okay, so in some of the projects, what we do, we always create success case studies and then we put it in a
Correct.
SharePoint drive. We also create a case study for failure patterns. Generally, people create case studies for success. That is fine, because even when I take interviews, I never ask questions on success case studies, because I know 99% of the candidate will come prepared on success case studies by Google, YouTube, and ChatGPT. So I never ask questions on success case studies. I ask them questions. Can you tell me your agile transformation failure or your data science model that got failed? Why it failed? And what is the root cause analysis? What you made to correct it? You believe me, most of the candidates will not answer those questions. They will talk about success only. Okay, because
Correct.
candidates have that mentality to exaggerate their capability in an interview. Companies also has that mentality to exaggerate their capabilities to get new clients. That's part of the game equation. But let us understand and then do it. That's what I'm trying to tell. So those are all some of the things which we need to take care. And just to paraphrase, any kind of a data science project, again, it boils down to three main concepts: input, process, output, right? Anything, be it a data science or an agile transformation or a digital transformation or an organization change management, anything and everything, input, process, output. This particular input can be mapped to the current state, right? And your output can be mapped to the envisaged or envisioned target state. This process is something which is going to take your audience from the input and then go to the output. I think if you segmentize into these three buckets, life will be more easy.
Well said, Balaji. So maybe the last question, obviously we already touched upon it, but to just put it explicitly. So maybe the last question. what are the common pitfalls that Scrum Masters and Agile coaches should avoid when implementing Agile in data science projects?
That's a very open-ended question. I may not say only this is the answer, but probably some thoughts I will say. One of the common pitfall is treating data science is also like any other software development project. Okay, so they are more focused on developing features rather than having that experimentation mindset in a data science project, which could be one of the pitfall. And people need to understand that any kind of a model you are trying to build will take time to get trained. So you need to align your expectations early with the business counterpart. Don't go and over promise the business impact to the business sponsor group. Okay, that is one thing. Ignoring the data quality means people may not give that much of impact to the quality of the data. Bad data will give you bad model. So always one need to have a checklist wherein you are checking your data pipelines need to be a continuous activity. And you may also need to explain the model to your business, right? Because if your stakeholders or your end users are not going to trust the model, psychologically, they are not going to use the model, right? If they're not even trusting the model, how are you going to use the finished solution or the product, which is a enhanced capability of this particular model? So if your stakeholders are not going to trust the model, probably they are not going to use the model. And also one of the pitfall is Scrum Masters and Agile coaches or even Agile project managers not really spending time with the ground level, though the technical team who is actually not trying. Okay, go ahead and then deploy the code without having proper monitoring capability. So these are all small things, and not having clearly defined ownership also. Who need to do which particular part? See, though it is a team, pragmatically everyone need to have a primary ownership on their own task, right? You cannot assign the activities of a data scientist to a business analyst. So those,
Exactly.
yeah, business analyst capability is something different, data scientist capability is something different. So having a clearly defined ownership, I think these are all some of the things which we need to take care. But then no one see, experience will allow you to fail fast or know the ecosystem within a shorter span of time. Even experienced people will have a struggle, but an experienced guy will pick up the momentum within a week's time. Probably a person who is not having that experience may take a month's time to prepare. The timeline matters.
Absolutely. Well said, Balaji. I mean, that's the great point. I think that is something all of us should remember, not just for this projects or this domain, but for any new thing that we are doing, right? So if we have experience, we don't have to fear failures, right? So it will help us cope up with the failures faster and maybe rise to the phoenix, right? So well said on that note. Thank you so much, Balaji, for coming over yet again and doing this podcast. This itself is a master class for people who want to get into this kind of a domain, data science or data engineering or AI kind of a domain as agile coaches and scrum masters. So that's a great conversation, I would say, and looking forward to more such conversations with you. Thank you so much for
Yeah,
doing this once again.
yeah, yeah. And for our information, I have a YouTube channel for Agile. So 4 months back, I started a channel for data science also. Okay.
Wow.
Yeah. So I started making some small videos on data science. Now I need to get up to the next level of really showing them some hands-on aspects in terms of Python or your Tableau. See, now one thing I just wanted to tell for as a closure thought to this video, there are two ways to learn data science from a pragmatic approach. And what my suggestion is, whichever way suits you, you actually go for that. Okay. One way is you spend learning only Python for 4 months. Okay. Or okay, first you begin with Python. You spend some 3 to 4 months. Then you begin with a Tableau, and then you spend some 2 to 3 months. So on and so forth. I slice the cake and then consume it piece by piece. Okay. This is one way of learning. The other way of learning is, if you're already an IT guy and you have that basic, the picking up knowledge kind of a capability, You start a use case, take a simple use case, and you now think through, okay, understood, this is the data science life cycle in a typical IT project. How am I going to build a model for this use case? How am I going to deploy the model to the production cloud instance? And how am I going to validate the model and train the model? And certain models, you can even use your personal laptop. Nothing prevents you from doing it. You can install your Python the free version, start doing some Python coding. And once you gain some so one thing is you take piece by piece and then try to integrate the knowledge. The second way is you take a use case and then try to funnel it through all the capabilities what I told. And then once you are able to solve the use case, now slightly increase the complexity of the use case. Generally, people tell the second way of doing is better than the first. But my suggestion is whatever makes utmost relevance to you, you can actually go, no, go for it. Okay, that is what. So you may need to try it out. What actually suits you better. Yeah, I just want to give a summary view on
Absolutely.
that. Okay.
Absolutely. And also you can share the YouTube link. We can add it in the description as well for the people who want to explore this field as well.
Okay, gladly.
Thank you so much for watching this episode patiently till the end. We hope you enjoyed the episode. We'll meet you again in the next episode. Till then, if you like our podcast show, then do like, share, subscribe, and let us know your feedback in the comment section. You can also listen to the episodes on Spotify, Apple Podcasts, Google Podcasts, Amazon Music, and Audible. Thank you.